This is the KCSE Mathematics Paper 1, that is KCSE 2025. I don't know how you feel about the paper, but I'm actually from talking with more than 200 students who sat for this exact paper. And let me tell you, minor, this paper is a bit so dangerous. To some extent, there are some questions that are a bit so much sweety and juicy, but actually that's where the problem begins, because so many questions in this paper look so much innocent and so much easy, but deep down in them, there are so many tricks that have been hidden in them. And therefore, I decided to take my time to record this particular tutorial, not only to show you step by step on how to tackle on each and every question, but even to do something that is not usually done most of the times, and that is getting to reveal the mind of the examiner. So therefore, what I'll be doing is that I'll be getting to reveal the mind of the examiner, getting to share with you how the traps were formed and how you can be able to avoid them. So it's very important that you get to follow keenly from the start of the video until the end of it, without skipping, so that you can be able to grasp every concept that I'll get to share all along. I believe this will make you to be much confident in mathematics. And actually, let's get right away into it. We have our question 1 right here with us, and we are taught, without using mathematical tables or a calculator, evaluate this expression that is right there, and that is the square root of 11 over 12 minus 1 over 3 divided by 1 over 2. Well, you see, you have been told that you are supposed to evaluate this without using mathematical tables. So by just getting to watch on this, that already communicates something, and that is the examiner is telling you, in other words, that what they are so much interested in is not the answer that you get, but the process that you do follow. Therefore, the things that you write, you have to write them in a way that shows that you never used a calculator. And let's go ahead and work out that. So we have 11 over 12. Well, you see, this is fraction, a fraction, and also this one is a fraction. But, well, we can be able to convert this one from a combined fraction to its a proper context like the other. So we have minus 1 over 3. And then what we do here, we have the division sign. So to be able to convert it into a proper fraction, what we do is that we have 2 multiplied by 1, we get a 2, plus 1, we get a 3, and then we have divide by 2, and remember we've got a square root here. And you see, when it's like this, there's so many students who usually go ahead and just minus here, and they say this is 11 over 12 because this one is a multiple of 3, and here we've got 3 here. Therefore, this one is much easier to do the minus, and that is a very deadly mistake. You see, everything that we have usually have protocols. Even when we are having gatherings, you will see, if it's a political gathering, you'll see the MCA speaking, and then MP, and then the governor, and then the CS if they are there, and then finally the president. Also in mathematics, as we get to work out these operations, there is a procedure and a protocol that we should always apply, and that is definitely none other than BODMAS. Very important. Therefore, what we first do is not what appears first, but what appears first in this structure that we use, and that is BODMAS. Since we don't have brackets, we don't have off, we simply start with the division. Therefore, we start with this part over here, and we apply a simple law that whenever you've got a division, we usually change the sign, especially if we are having fractions on the left and the right side of it. We convert that one to a multiplication, and then we invert what comes after that sign, and that is this 3 over 2. Therefore, we reciprocate that, and once you do that, you are going to get 2 over 3. Everything else remains as it was, like that. And remember, don't forget this square root sign. Finally, we can be able to do this multiplication. We have 1 over 3 times 2 over 3. We can multiply the numerators, that is 1 multiplied by 2, that's gonna give you a 2, And we have the denominators as 3 by 3. That's going to give you a 9. The question is actually becoming a bit much simpler because here we have now 11 over 12. Therefore, we just simply write it here 12. And then we have square root. Great, amazing. So we are having 11 over 12, and this one you are supposed to minus 2 over 9. What we use here is that we try to find the LCM of these numbers, 12 and 9. The LCM of these numbers is 36. Therefore, we do 36 divided by 12. That's going to give you a 3 multiplied by 11. That's going to give you a 33. And then we've got a minus 36 divided by 9. That's going to give you a 4. And then a 4 multiplied by a 2. That's going to give you an 8. And remember what you have there is a square root sign. You have to carry it all along. So this is like a key that is giving you access to each and every step. If you forget it, then also the marks that are here, you are likely to be penalized on that. So we have 33 minus 8. That's the same as 30 minus 5. That's supposed to be 25 over 36. And we have the square root of that. So finally, we complete up this step. So we find the square root of each and every component. We can find the square root of 25. That's going to give you a 5. And the square root of 36. That's going to give you a 6. But unfortunately, many students just left it at that comfortably and said, finally found the solution. Don't make this mistake, because each and every time that you are finding the square root of something, always remember and know that the square root of something is equals to positive or minus the results that you get. Therefore, the required solution is supposed to be plus or minus 5 over 6. If you just leave it at 5 over 6, then you are going to lose the answer mark. Therefore, you are just going to get 2 marks. So that you are really able to get the full marks, then you should be able to really be able to write plus or minus 5 over 6. And then the other 2 marks, you are going to get them along the procedures. The first one being able to work out this part, that is being able to convert this sign to a multiplication sign, and then being able to reciprocate that, and then finally being able to get to a point where you are going to the second step of now minusing, in order to be able to get all your full marks for that. And that is how you are supposed to solve that question. And normally, question 1 usually gets a very easy question, and this is the psychology of the examiner, though this is something that is not usually spoken about. Normally, they'll give you just a simple question so that your mind can really relax a bit. And when your mind really relaxes so much, what usually happens to you is that you don't become so alert, and therefore you are likely to make up some simple mistakes like this one over here. So ensure that you don't fall into that trap by ensuring that you are fully alert and you remember all the concepts that you were taught. Let's get into the second question over here. A very awesome question. I see it's touching a bit about money. And well, we have Baraka earns shillings 210 per hour working at a supermarket. The employer changed the amount earned per hour in the ratio of 8:7. Determine the amount that Baraka would earn in 10.5 hours at the new rate. You see, this question really contains a lot of sentences, but now it is your work as a mathematician to be able now to simplify all these. And that is why you usually say that as we do mathematics, what we are doing is that we are finding the solution, and finding the solution of something is getting to move from the problem to now the desired solution that it's supposed to be given as an output. And that is exactly what we do. The first thing to know is to determine the new payment. You see, this one was the old payment, that is 210. This is old. That is shillings 210. We need to determine the new one. You see, the new one is now 8:7 of the old one. And you see, when you've got a ratio 8:7, that implies that it is 8 that has been divided by 7, but then we are multiplying that with the old value because this is now the new ratio, the new and amount, which is 8/7 multiplied by 210. I believe that we can be able to handle this because divide by 7 1, divide by 7 3, 0, 8 times 3, that's 2 4. So the new amount is shillings 240 per hour. This is very important because you are having him being paid shillings 240. This one is per 1 hour. But the question is asking us about 10.5 hours. What about 10.5 hours? Therefore, simply what we do is that we do cross multiplication in order to get the amount that is going to get. Therefore, that's 240 multiplied by 10.5. Wow, amazing. This is really so cool because we can be able to convert this one in a way that we can be able to do the division quickly. So we have 10 multiplied by 2, that's 20 plus 121/2. What we have here is divide by 1, divide by 2, 120. And finally, we get to do 120 multiplied by 21. That's going to give you shillings 25, 20. And you realize this is really interesting. So this is actually the required solution for that. If you do that, then you should really be able to get all the full marks for that. But you realize that here, there was a very serious trick over here. Because you see, there are some students who took this ratio and said that what you're really supposed to do is that you are supposed to take this one, the number that is here, 7/8, and then you multiply that with 210. And you see, the amazing thing with this is that you'll just do, so what they did is 210 divided by 8. What do we get with that? It's going to give you 26.25, and then they went ahead and multiplied by 7. You see, if you do this is very wrong. So what you're really supposed to check is about this ratio. If this number that starts here is bigger, then that implies that the final amount that you get here, which is 240, it should be bigger than this one because this is an increasing ratio. If it was a reducing ratio, then that would imply that the amount that you get here would have been smaller. And you see how serious it is when it comes to calculation, because imagine the person who was doing this calculation is an accountant, and now this is a guy who have been employed somewhere, and now it's supposed to be paid a new amount after some calculations have been done. You see, this accountant, if this accountant makes any mistakes, therefore that implies that he would make this guy who is here to just suffer for nothing. And this is what we call mathematical robbing. You see, mathematical robbing, this is where you rob a person very easily, without using even force, without using a gun, but by just doing wrongly calculations. Sometimes maybe calculating an amount that the person is supposed to be paid, and then you remove the last zero, which is quite significant. Let's say a person was supposed to be paid 520,000, and then along the lines you just remove 10, and this sounds to be a very simple mistake, and this is likely to happen. So you'll find like this amount will now become 52,000 just because someone just did a very slight mistake. And that is why in mathematics, when you make a mistake, even if like you opted out this 0, or maybe you left this 2, therefore you will not be given the final answer is correct, because we also really need accuracy in your final answer, because we really understand how that is important and how that really plays in a real life situation. Let's get quickly to the next question over here. We are told solve for x in the equation 4 to power 3x multiplied by 8 is equals to 1 over 32 to power 2x minus 3. Wow, this really looks so much interesting because these individuals are what we call numbers. Normally, I love treating numbers like people. You see, if these were people, then I would say that these people are somehow like siblings because there is a way that they are really related, and that is they share a common number, which is a multiple to all, and that is 2. Therefore, we can try to convert them to a multiple of 2 so that we can be able to equalize them so that they can look a bit much similar, and that is how we start creating patterns. Therefore, instead of writing 4, what you're really going to do is that we are going to write 2 to power 2 over there, but then don't forget what is here, that is 3 to power x. And then we have that multiplied by 8 is equivalent to 2 to power 3. And then on the other side, that is on the right side, we have 1 over 32. You see, 1 over 32 is equivalent to 1 over, this is 32. 32 should be equivalent to 2 to power 5. And then we have all that to power 2x minus 3 like that. Amazing. So we can go ahead and try to open up these brackets. The law that we are really using here is this law, that is, if you have got a to power m, and that is multiplied by n to power n, then this one is equivalent to a to power mn. This is the law that is being tested right there. And that is what we get to apply here. So we have 2. So we do 2 multiplied by 3x. That's going to give you 6x. That sounds better. We have 2 to power 3. But then if you look at these, something interesting over here, you're going to notice that, you see these guys, it's like this is like a house, and you find like these guys are there in the ground floor, but there's this guy, this fellow over here, is there in the underground. Why don't we just bring him to the ground floor also? And we can really be able to do that. But now as we do that, there's something that happens, and that is when we get to apply this law that whenever you got 1 over a to power m, this one is always equivalent to a to power negative m. So when we are shifting something from the denominator to the numerator, what we usually do is that we usually negate the power. Therefore, as this guy gets to transform from here to move upward, there's something that is going to happen, and that is we are going to add him something over here, and that is we are going to give him an opposite sign to which was here. So if this was 2 to power positive 5, it's gonna be 2 to power negative 5, and everything else remains the same, 2x minus 3. So we can go ahead. You see these guys, they are now a bit closer, and if they are a bit closer, and you see how I was telling you that all these individuals, they are really related because we have 2 to power something now, and 2 to power something, 2 to power something, which makes our work much easier, because now what remains is that since they are fully related, we can put them together, and once we put them together, they are going to share a common place, and the place that they are sharing is 2. But because they have come together, what we do is that we bring them together as they are, and that is 6x. We bring also this other individual together, and we add them together like that, and remember they are sharing a common point too. So there is a law that you are really applying here, which is quite important, and this is the law that we are applying. I wanted to really get to write these laws for you somewhere so that you can easily be able to copy, and that is when you've got something like a to power m, and it is multiplied by something to do with a to power n, that one will always be equivalent to a to power m plus n. This is the law that is being tested over there, like that. So what we do is that we retain the bases, of the numbers, which is a, and then we add the power same plus n. We retain the base, which is 2, and then we add the power 6x plus 3. And then on the other side, what we have is that we have 2. So what we get to apply here is again this law that we have here. That is a to power m to power n is equivalent to a to power mn. So we have -5. And here you have to be very careful because of the signs that are here. So we have -5 multiplied by 2x, that's going to give you a -10x. And then this is the part to be much careful in. You have -5 multiplied by -3. That should give you a positive 15. Because this is actually the part that many students made quite a lot of a mistake right at this point. That is -5 multiplied by this part over here, because there are students who just took this is a negative here and then they just did 5 times 3 and they wrote -15, which is really so much wrong. Since we have these guys like this and they are sharing rooms that are really opposite to each other, but we say that these people, you see that they are related because this one is a 2 and this one is a 2, and this is their kids, this is their kids, this is their kids. So we can also say that their kids are also related. That is 6x plus 3. We take the kids as they are, 6x plus 3, and on the other end we have -10x plus 15. Mathematically speaking, the law that we apply here is that when you've got a to power m and you see that this one is equivalent to 2 to power a to power n, then that implies m should be equivalent to n. This is another law that you should note down like that. So finally, what you do in this equation is that you try to simplify that. We can take -10x to this other side, and it changes the sign to a positive 10x is equals to, we have 15 here, and then we minus this 3. What you're doing here is taking 3 to the other side, it changes the sign. We have 10 plus 6, that's going to give me a 16x is equals to 15 minus 3. That's gonna give me a 12. We divide by 16 on each and every side, divide by 16. When I divide this by 2, I get a 6. When I divide this by 2, I get an 8. When I divide by 2, I get a 3. When I divide by 2, I get a 4. Therefore, finally, what I get is 3 over 4. But also, you can also write 0.75. So if you give your final answer as 0.75, that's correct. If you give it at 3 over 4, that's also very correct, because it was not specified whether you should give your final answer in terms of a decimal or in terms of a fraction. So if it's not told, you can always leave it in either of them. But the most important thing here to note is this formula that is right here, and also this formula, and also this formula, and also how to apply that. Because if you just get to master these formulas and you know how to apply them, then working through this is much easier. And another thing is always to check on whether you can be able to convert these numbers into a similar base as we did by converting all the numbers that we had in terms of the multiples of 2. And that is how we were really able to get to a point where we are really getting the solution of that. Let's move ahead. I believe that you're really learning and that you're also getting to see the formulas that you're really supposed to apply together with the areas that were a bit tricky and where many people went wrong. For this particular question, it was this part of getting to open up the brackets. Always be double keen and double alert. So let's proceed on with our question 4. I see this is a very wonderful, interesting question as well. And actually, as we progress, ensure that you have really subscribed to this channel so that you don't really miss the tutorials that we get to upload. What we're having here, this is a question that really somehow looks a bit different from the actual questions that are usually tested because of the format that it has. But the bottom line is to ensure that you get to work on these cases independently and then later on get to combine them together. Let me go ahead and explain that to you. So you'll notice that before we move on to that step, you'll notice that what we have here is simply a number, but here what we have is a fraction, and here we have a variable x, and we have now a digit and a digit. So the first thing that we do is to really find a way of eliminating these three. You see how it looks a bit unorderly, having something that is a fraction and then the others are numbers. So what you do is that we multiply everywhere by 3, and that is exactly what you're going to do. So we multiply here by 3, we multiply here by 3, and also we multiply this part by 3. Let's go ahead and do that. So what we get here is -1 multiplied by 3. That's going to give us a -3. We have less or equal to, this 3 cancels out to have 5 minus 2x is less than. We multiply this by 3, that's going to give us 6x. You know, when we are multiplying this by 3, we are multiplying basically everything that is inside the brackets. So we have 3 by 2x, that's 6x, and then we have a minus 1 by 3, that's gonna give you a 3. I don't know if you remember a certain case that was there of a certain king by King Solomon, where there was two mothers who were fighting for the same kid. And then, do you remember the argument of King Solomon? King Solomon said, or rather suggested to both the two mothers, whether they could just split the kid in order to see how they would reason, and that would help him be able to tell who the mother of the child was. And definitely one of the one of the mothers who was claiming that the kid is hers, what she said that, wow, yeah, we should split the kid because none of us has accepted one to take the kid. And then the other mother who was claiming that the kid is hers said that no, we cannot split the kid. And I don't know if you are that king, I don't know the approach that you could have used. But now here is now mathematical stuff that you are really solving over here. But this one, what we are having here is that we are having a number on this side, -3, and also another one on this side. And we want to split them a bit. And we cannot divide this one into 2. We cannot say that this part is going to go with 5 and then this part is going to go with -2x. It's not possible. But now what we do mathematically is that we create a fair scenario where we take the whole of this case up to there. We say that you who is fighting for this kid who is here, we are going to give you the kid, and also the other person who is on the right side, we are also going to give him the kid also. Therefore, what really happens is that we end up having these cases, and that is -3 is less or equal to 5 minus 2x. And similarly, we also retain this. It's kind of like this number figure over here has been duplicated. Therefore, on the right side, we're also going to have 5 minus 2x, because this one is a relationship, 6x minus 3, like that, such that we are going to have two inequalities. We have the first inequality there and also the second inequality there. So that now what remains for us is now to solve the two inequalities, and then after we get the solution, we'll then get back and try to combine them. So for such a case, what do we have? We have -3, we have 5, we have -2x. So we can try and push this -2x to the other side, and that's gonna be a positive 2x. We have the sign there, and then we have 5 plus 3. We pick -3 to this other side to have it as +3. So finally we have 2x is less or equal to 8. We can divide by 2, we can divide by 2 there, and that's gonna give us x is less or equal to 4. let's go to this other part over here. What's the best approach to go about that? In order so that we can get rid of trying to deal with negatives a lot, we can take this 2x to the other side and negative 3 to the other side, such that on this side we are going to remain with 5, and then we take this 3 to this side to have positive 3. The sign remains the way it is, that is the inequality, and then on the right side we are going to remain with 6x, and then we have negative 2x, we pick it to the other side, we have plus 2x, and finally we have 5 plus 3, 8 is less than 6x plus 2x, that's 8x. We simply divide by 8 to get 1 is less than x. So finally, which inequalities do we get? We have this inequality over here, and that is 1 is less than x. So we have 1 is less than x, and this other one we have x is less or equal to 4. So these are the two inequalities. But if you really check at this very keenly, there's something that you are really going to notice over here. And that is, you have this x over here and this x over here and this x over here. So if you can put this one together such that you have a combined inequality as it has been outlined, therefore you'd have something like 1 is less than this x. At the same time, this x which is here, this x, it is less or equal to 4, like that. And actually, that's how really you are supposed to solve about that question, and that is the required solution. If you are really able to follow all those steps, the procedures, then you should really be able to get your full marks for that. One, for getting the first inequality, the second one, and also being able to put them together, all that accumulates to the 3 marks that you're really supposed to get. But the most critical part is to be able to first convert this inequality in a way that we don't have fractions, and after doing that, being able now to subdivide it into 2 inequalities such that they are mathematically correct. Remember what I said, that you cannot split this one right here and say that this negative 2x belongs to the right side and 5 belongs to the left side. No, you cannot do that. That is a mathematical injustice, and that is a crime that is quite punishable, because when you go out there, you'll start saying, because there's a kid and there are some people who are fighting over that kid, you'll say, let's just divide that kid into 2. You see, that is really, really totally wrong. Yeah, but let's keep moving on. We have our next question over here. That's really question 5. Remember, this is KCSE Mathematics questions that were recently tested. Therefore, this is a KCSE standard exam. We have the following figure represents a rectangular farm PQRS of length 210 meters and width 120 meters drawn on a grid of 1 centimeter squares. The dotted area inside the farm represents a flooded section. Estimate in meters squared the area of the farm that is not flooded. Oh, this is quite unfortunate for the person who owns this farm, because it's really getting flooded, all this section. Therefore, that implies that almost all of this land gets into some sort of a waste note unless they find a solution. But well, that is the concern of the farmer. Us as mathematicians, our concern is to be able to estimate the asked part, and that is the area of the farm that is not flooded. And there's something which is quite unfortunate. You see, normally when you see these kind of questions, a lot of students, I don't know what really happens in their mind, but they ran and rushed to just calculate the estimated area of the dotted part. I don't know if it's because it occurs by default that when you've got such a shape, you're supposed to find the area of the shaded part. But now here was a trick, and that is why you have to be really so much keen as you read the question, because it is telling us estimate in meters squared the area of the farm that is not, this word is very important, is not flooded. Therefore, the part that you're really finding is the part that is not flooded. But how do we get to estimate this? Normally, you'll find like here we've got a section of a square that is flooded, a section, a section, a section, a section. So normally, we usually take the full sections, and then let's create some space over here. So we are going to take the full section over here, and that is this one, and then we add with all the other sections that are not full, and then we divide by 2 to convert them to full sections rather. So we have the first one here. This one, it is full. Therefore, we take it the way it is, like that. For these other ones, we are just going to take the ones that are not full. So we have the first one here. We have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Therefore, the sections that are not full are 12. We have to divide by 2 so that we can get the value of the full sections for that. So this one is going to give us the value of these sections, or rather their area, in centimeters squared. So let's go ahead and add this. This is 12 minus 2. What's really that's supposed to give us? That's supposed to give us a 6. 6 plus 1, that's 7. Therefore, that's supposed to give us 7 centimeters squared. But we are not yet done, because what the question is telling us is that you see, the following figure represents rectangular farm PQRS of length 210 meters and 120 meters drawn on a grid of 1 centimeter squares. You see, this is 210 by 120 meters squared. So this is 210 meter by 120 meters. This one is represented by how many squares? 1, 2, 3, 4. 4 by 1, 2, 3, 4, 5, 6, 7. 4 by 7. So we can actually start by this. This is 7 times 4. That's 28. So this is 28 centimeters squared represents, this is 210 times 120. 210 times 120, that's giving me 25,200. 25,200, and that is meter squared. So we ask ourselves, what about 7 centimeters squared? 7 centimeters squared. We simply have to do cross multiplication. So therefore, you're going to do 7 multiplied by this figure, 25,200. And then we divide that one by now 28. We divide by this 28. That is going to give us 6,300 meters squared. So notice that now this one is the area of the shaded part, and that is the flooded part. Flooded part. So to get the area of the part that's not flooded, Many students may have been tempted to leave it at this, which is really wrong. So don't make that mistake. So to be able to find the part of the shape that is not flooded, we do the whole shape, which we found to be 25 to 100. And then we minus 6300. What do we get by doing this? 25 to 100 minus 6300. That's gonna give me 18900. And remember to put the units, that is in meter squared. And that is the exact required solution for that. And well, this is the easiest way to work it out. However, there is another way that you can use to find the solution of this, and that is you can calculate directly the area that is not flooded. But how do you do that? So you'll start by taking the full squares, like this one: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Do we have any other one that is full? Not really. So you'll just take that 15 and then you add to the other ones that are not full. The other ones that are not full. So there's this one. We could have used a different color. The other one that's not full, it's this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That are 12. Yeah, it's actually, there are 12 of them. And then once you have that, you're going to do 12 minus divided by 2. And then the value that you get there, you are going now to have it as in terms of centimeters squared, and then you are going to now convert that one using this scale that we have here to be meters squared. And actually it will be a nice exercise if you get to try it on your own, to see if it will give you an exact value to the other method, but definitely it should. So that is it for that question 5. But the most important thing is to be able to read the question carefully, to be able to understand what the question is asking, because this is the part that was really so much costly. And then from there to be able to calculate well the squares that are there. But this is the most straightforward way to go about that. Though this is a question that is not really so much tested, but it's a good question to test on your logic and also to test on your alertness and carefulness as you get to tackle mathematics questions. Let's move on to another amazing question, question 6. And actually, I really love this question, and let's get into it and you'll be able to understand why. We have a relief organization donated to 40 kgs of maize and 150 kgs of beans to needy families. And then the question goes ahead and tells us that each family received exactly the same quantity by mass of either maize or beans. And then we are told that no family received both. We are then told determine the least possible number of needy families. The reason that I say that this question is a very interesting one and a very juicy one, it's because you see, determine the least possible. So the moment that many students saw this least possible, they actually never gave it even a second thought. And this makes this question to be very dangerous, because they saw that this is asking about least. The list is just about LCM. And then they just went ahead and just worked out the LCM of these, and then they said, that was really quite so much simple, and then they thought that they got the 3 marks. But unfortunately, by doing that, you don't even get a mark. Why? Because you've even done it wrong, even in the first step. This was testing on your logic and how best you can be able to reason on such a situation. You see, if we are really supposed to get the least possible number of needy families, then that implies, so that we can get the least possible, then we should be able to divide these numbers by their greatest divisor. And that is where the trick lied for this question. Therefore, this question required you to first find the greatest common divisor for both 240 kg and 150 kg. And let's go ahead and do that first. And then from there, I'll show you what to do next. So we have 240 and 150. We are finding the greatest common divisor. So we divide by 2, we get 120, we get 75 there. Can you divide by 2 again? Not really, because 2 is not divisible by 75. Therefore, we just have to put it at that. And then we check out on the next number that we can divide with. So the next number is a 3. So we divide by 3. Here we get a 40. I believe 75 by 3 it's 25. And then finally we divide by 5. We get an 8. We get a 5. There's no any other number that we can really be able to divide with such that we are able to get a whole number. Therefore, the greatest common divisor, it's supposed to be 2 multiplied by 3 by 5, and that's gonna give you 5 by 3, 15 by 2, that's 30. So these are 240 kgs where let's get back to the question. It's really very important. A relief organization donated 240 kg of maize and 150 kgs of beans to needy families. Each family received exactly the same quantity by mass of either maize or beans. No family received both. Determine the least possible number of needy families. So, to be able to determine this, therefore that implies that these 240 kgs were divided in terms of 30 kgs bags. Similarly to 150 kgs, they were divided in terms of 30 kgs bags. So to be able to get these families, the families that got maize will be definitely 240 are divided by the number of bags. So these are the families that got maize, and the families that got now beans will definitely be 150 divided by the number of kgs per bag, because the total number of bags are 150 and they are divided into smaller units of 30 kg, 30 kg, 30 kg, 30 kg, and so on until we have a total of 150 kgs. So to be able to get the number of those smaller 30 kg, we definitely do 150 kg divided by 30. So these are families that will receive beans, and these are families that are going to receive maize. And in order to get the total number of families that received both, we definitely have to add the results. So we have 24 to 40 divided by 30, divide by 10, divide by 10, 24 by 3, we get an 8. Here by 10 by 10, 15 by 3, we get 5. I believe that's so. And finally, we have 8 plus 5, and that's gonna give you 13. And remember, these are families. And that is how you are really supposed to go about that. At first, you may see this question and think, oh, these are very simple, easy question. And you just go ahead and just find the LCM, just to find later on that that is not what you are really supposed to do. You are really supposed to really read the question correctly and being able to argue out well, and do so that with the mathematical principles that are going to help you to work out that correctly. So with that, let's move on to question 7. And these are questions that can also land you into trouble if you don't get to check on it quite well and with a lot of carefulness, because it can be an atomic bomb to you, because there's someone who may be tempted to just come at this question and just check, here we just have an x squared, and then they just cancel it out. We have an x squared, they just cancel it out. We have a y squared, we just cancel it out. We have a y squared, we cancel it out. And then they say we have 4 divided, we have a 4, they divide by 4. We have a 4, divide by 4. And then they say, this one is just equal to negative 1 over xy. And they say, that was really pretty, it's just 3 marks, but just doing that and you get your 3 marks, which is definitely totally incorrect. So the best thing is that you're going to do some surgery to this equation in a way that you're really going to separate the upper side from the lower side, and that is what we call the numerator and denominator. So we start with the numerator. Numerator, we are having x squared minus 4y squared. So what you're going to notice for this is that this one is a difference of two squares. Just as we have a case like a squared minus b squared, this case is always supposed to give you a plus b multiplied by a minus b. So definitely what we do is that we find the square root of this, that's going to give you an x, and then you put an addition sign, and then you find the square root of this, and you find the square root. You are supposed to find the square root of all these 4y squared, the whole of this. You see the square root of 4 is a 2, and the square root of y is a y. That's a place that also many students made a mistake, and then you just have it the same way as it is, only that you alter the sign to be a negative. So for the numerator, a simplified version of it, we get it like this. And finally, we can go now to the numerator. For the numerator, what you're having is x squared plus 4xy plus 4y squared. So we want to find a way in which we can be able to factorize this expression that we have here. So we are going to look for two numbers such that the product is 4 and the sum is 4. I believe that is pretty much easy to find because that's supposed to be 2 and 2, because 2 plus 2 is 4 and 2 multiplied by 2 is 4. So definitely we pick x squared and then we add. Instead of writing 4xy, we are going to write 2xy plus 2xy. Notice that this one doesn't change the value of this part, because 2xy plus 2xy is equivalent to 4xy. It is only that we have expanded it a bit so that we are able to do some factorization. So here we pair them into two like that. We find the common term here, the common term between x squared and 2xy. That's supposed to be x. We factor it out to remain with an x there, plus once we factor out this x, we are going to remain with this 2 and this y. Therefore, we have 2 and y there. And then we have plus what is common between here and here. It's definitely this y. This y. We factor it out. Here, if we factor out the y, what should we really get here if we factor out the y? This is supposed to give me actually we can be able to factor out the y, but also you'll notice that there is also a number here. There is a 2 and a 4. What's the common number between 2 and 4? It's a 2. Therefore, we can also be able to factor out 2. Therefore, what we'll factor out here is both 2 and this y to remain with this x. Therefore, we should have that x, and then we have the plus sign over there. Here we factor out 2 and y. When we factor out 1, 2, we are going to remain with 1, 2 there. And once we factor out y, we are going to remain with only 1y inside. And definitely to be able to put this together, we usually pick the first term and the other term that follows, that is x plus 2y. And then finally we pick what is there inside the brackets, which is x plus 2y, like that. And finally, what you are going to do is that you are going to pick what is there in the numerator divided by what we have in the denominator. In the numerator, we got x plus 2y. That's multiplied by x minus 2y, like that. And now for the denominator, we have gotten x plus 2y. and that is multiplied by x plus 2y, like that. So that is the part that you are getting for the numerator and the denominator. So what really remains for us is just now to just simplify this. Do you have any common terms? You have x plus 2y, we have x plus 2y, and we are going to remain with x minus 2y, x plus 2y. And that's the required solution for that. That's how really you are supposed to talk about that. But there's one thing that I really observe when I try to check the working of a number of students after they get this case and they realize that we have an x, we have an x, we have a 2y, they usually try to, I don't know how to put out -1 and try to force out this equation in a way that it will become x plus 2y. And that is not really quite doable because we already have a positive sign here. So there's no any way that you can be able to transform this one, x minus 2y, to be x plus 2y. Similarly, there's no any way that you can be able to convert this one, x plus 2y, to be x minus 2y such that you can divide them. So the last stage and step that you leave this equation at is as x minus 2y divided by x plus 2y. But one very key important thing to remember in this equation is this formula. Normally, it's usually tested. Once you see an equation of this nature, mostly they usually test this concept. And the other concept is whether you know how to factorize. You know how to factorize. So this is the first thing. And the second thing is how to factorize. If you can be able to master those two things, then you've really mastered how to work out such a question. So let's keep going and let's see the next question, how it really looks like. But I believe it's really a nice one for our practice. Amazing. I love this. We are told that the area of a sector of a circle is 550 centimeters squared. And then the question goes ahead and tells us that the sector is curved to form an open cone of radius 7 centimeters. Calculate the height of the cone. Calculate the height of the cone. So how does a sector look like? A sector of a circle, it's usually something like this. Yeah, just forgive my drawing skills, but I'll need to learn some math. So this is the sector of a circle with the area of 550 centimeters squared. I don't know who's going to teach me some maths, but it's a very wonderful skill. So we are told that this one is equivalent to 550 centimeters squared. This is just an illustration. And then we are told that this one is folded to form an open cone. A cone looks something like this. This is just a sketch, right? So this is what will be formed, and we are told that it's open and it has a radius of 7 centimeters. So I'm assuming that radius flows like this, and assume that this one is the center. And then we have this part over here. This is the one that is 7 centimeters, like that. So that is 7 centimeters. Let's now get back to the question. We are told it forms that cone. Oh, calculate the height of the cone. Calculate the height of the cone. So if this cone is a curved, you are supposed to know how to calculate the surface area of a curved cone. How do we go about that? Curved surface area. Curved surface area. It's important to note that it is curved. You know, sometimes this might be interpreted to mean cross-sectional area, which is not the case for what you are doing. So this is to mean curved surface area of cone of the cone. How do you find it? We usually find it by pi RL. And you realize that this is the material that was used to create this one. And we are told that there is no any wastage. Therefore, the area, the surface area of this one is equivalent to the surface area of this one. Therefore, pi RL should be able to give you this area, that is 550 centimeter squared. Pi, we have not been given a preference, therefore we use the one that is default, 22/7. And lucky enough, the radius here is a 7, therefore it's not going to give us a lot of trouble. And then we have multiplied by L is equals to 550, like that. Divide by 7, divide by 7, we have 22L is equals to 550. What do we do to remain with L? We divide by 22, we divide by 22. Divide by 22, 1. We remain with L is equals to, oh, this is amazing. Can we divide by 11 here? If we divide by 11, we get a 2. If we divide by 11, what we get there? 11, 5. Yeah, it should be 5. And then this 0. Finally, 50 divided by 2, that's 25 centimeters. So that's now the length. But now the question is telling us to calculate what? The height of the cone. If this is 7, we can be able to calculate this height. This is the height that you are being told to calculate. But now this L, remember L represents the length from here to here. Therefore this part is 25 centimeters. Actually, I can plot it for you here so that you can be able to visualize that quite more clearly. So that implies that this part is 25 and this part is 7, and then we are supposed to calculate this part over here. And remember, this line is running from upwards to this part, therefore what we have here is 90 degrees, like that. So to be able to get the value of height, we can try to use the association of the Pythagoras theorem, where we have h, which is here, squared, plus this 7 over here squared should be equivalent to this 25 squared. Oh, this is h squared, nothing much we can do about it for now, plus 49 is equals to 25 squared, that's gonna give you 625. And then we have h squared is equals to, we can do 625 minus 49. That's something that you can be able to work out quite easily with your calculator, and that's gonna give you 576. Finally, you find the square root, you find the square root, this is gonna give you h is equals to the square root of 576, that's gonna give you a 24. And remember to input the units, because the units were given there as centimeters, therefore you write 24 centimeters, and that is how you are really supposed to go about that. So for this particular question, what it was really getting to test you, whether you know, is that we can be able to convert a sector of a circle into a cone, because you see, if you fold this part such that this part gets to combine, or rather gets to meet these points, and you fold it in a nice way, therefore what you are going to end up getting is this particular shape that is here, and that is a cone. And what happens is that this length from here to here becomes the length from here to here, and this part over here, because you never know the next time how it's going to be asked about, this part from here to here, which is the radius, or rather the circumference of this particular part, becomes now the whole circumference that is right here, like that. So that is how it gets to transform. But now for this particular case, what you are told to find is now the height of the cone. And getting to find the height of the cone, that was testing whether you really know how to apply the Pythagoras theorem. And that's how we really get to apply that. So with that, I believe we can move on to our next question. Remember that this is a KCSE standard exam. Therefore, each and every question that you are tackling is of great importance. So we are told in this question that a clock which loses 18 seconds every hour was set to read the correct time at 8 a.m. on Monday. And then we are told determine the time in 12-hour system. The clock will read on the following Saturday at 11:20 a.m. Such an amazing question. And actually, the reason that makes me to really love this question is because this is something that is quite practical. It's something that somehow it's likely to occur in a real life situation. Therefore, it's a good question to really work on. And let's really get to check on it together. We are told that this is a clock that is losing 18 seconds every hour. So the easiest way to first secure your first one mark is by getting to find the actual time difference between this date, which is 8 a.m. on Monday, to this particular date that is Saturday at 11:20 a.m. Therefore, you're going to subtract the time from Saturday back the way to Monday. And let's go ahead and do that. So we want to get the time from Saturday, or rather actually starting from Monday, the time from Monday to Saturday. So from Monday to Saturday, how many days are those? So Monday to Saturday. So we have the first day being Monday to Tuesday to Wednesday to Thursday to Friday and finally to Sunday. So those are 5 days. And now we have this other time, 8 a.m. to 11:20 a.m. How many hours are those? You see 8 to 9, 9 to 10 to 11. So those are 3 hours, 20 minutes. So the total time from Monday 8 a.m. to Saturday 11:20 a.m. is 5 days, 3 hours, 20 minutes. Let's have it here. 5 days, 3 hours, 20 minutes. That's the time that it takes to move from Monday 8 a.m. to Saturday 11:20 a.m. But you see this one, it's kind of somehow mixed up because you have days, you have hours, you have minutes, and later on here we are really dealing with seconds and hours. So it's a good idea if we can convert all these into something that is similar. For our case, to make our work easier, we can convert this one into hours. So let's convert the 5 days into hours. We know that in a day we have 24 hours, therefore we multiply that one by 24. This one, it doesn't change much because it's already in hours, therefore for that one it's really fully sorted out. And then finally we have 20 minutes. The 20 minutes, to be able to convert them to hours, what we do is that we divide by 60 like that. So we have 5 by 24, that's going to give you 120. And then we have 120 plus 3. And then we have plus 20 divided by 60, that's 1 over 3. So finally we have 120 plus 3, that's 123 and 1 over 3 hours. You see, right now it becomes a bit much awesome for us and quite easier to deal with because we now have it in terms of hours. Therefore, from Monday 8 a.m. to Saturday 11:20 a.m., the time that has really passed out is 123, 1 over 3 hours. Actually, we can convert this one to a proper fraction where we have 123 multiplied by 3. What do we get? 123 by 3, that's giving me 369 plus 1, that's 370. Over 3 hours. Let's get back to the question and see what the question is telling us. We are told that the clock is losing 18 seconds every hour. Therefore, this is 18 seconds, and it's important that you be very careful on this part. So this is 18 seconds, and the 18 seconds are being lost on each and every hour. So if it's an hour, therefore that is 1 hour. We write it there. And then the what we have in question is that we are having now 370 over 3 hours. Therefore, we have to write it here, 370 over 3 hours. This is what we want to determine. We want to determine how many seconds has been lost from Monday 8 a.m. to Saturday 11:20 a.m. Therefore, to be able to determine that, we have to do this cross multiplication over here. Therefore, that's going to give us 370 over 3 multiplied by 18, like that. So we divide by 3, 1, divide by 3, 6. This is 370 by 6. What do we get by that? That's something that is a bit much doable with a lot of ease. That's going to give us 22 seconds. Okay, so these are seconds. Can we convert this one to minutes? I believe we can be able to do that. So to be able to convert them to minutes, we divide by 60. Dividing by 60, we simply multiply by 1 over 60, and this one is going to give us 37 minutes. Oh, this is quite interesting. Can you try to picture that in your mind? That you're having a clock that is losing 18 seconds every hour, and then you'll see that now from this particular day on Monday, by the time that you are on Saturday, this clock will have lost 37 minutes. You see how the principle of accumulation is very powerful, because these small seconds, they have accumulated up to 37 minutes. Therefore, if you are not very careful, this watch might really get to mess up you a lot, because if somehow you are supposed to meet with someone at 9 a.m., therefore you are likely to meet with that person some minutes later, and actually it might make you to be a bit late for an important meeting if you are really heading for that. But the main interest for this is to be able to calculate what the question is requiring us to do. And let's get back to the question. The question is telling us, determine the time in 12-hour system the clock will read on the following Saturday. So the time that it will read on the following Saturday. So the actual time that it's supposed to read is this one, 11:20. But now this clock has lost 37 minutes. So what we do is that we minus. Again, this question is pretty good because it is also testing whether you know how to subtract time and what you do when you are in such situations like this one. Because if you look at this very keenly, you'll notice that what we have here is 20, and definitely it's not possible to do 20 minus 37 in time. So what you do is that you come here and you say this is your neighbor, and you borrow this one from this neighbor, which is from 11. So your neighbor is going to remain with 10 because you have borrowed one. But the moment that you borrow one, you remember what you have borrowed here is not just simply a 1, but it is 1 hour. And on this other side, what you're having on this particular end is minutes. Therefore, that hour, as it gets to cross over this junction over here, then it comes as minutes. And how many minutes are there in 1 hour? Definitely that's 60. Therefore, what you're going to have here is now 60 plus this 20 that you had, and that's gonna be 80. Therefore, what you're subtracting is now 80 minus 37. That's quite doable because we have 10 minus 7, that's 3, and then we remain with 7 here. 7 minus 3, that's supposed to give you a 4, and then on this other end what you are having is a 10. And remember, this is time, it's in AM, it has not yet changed to PM or any other time zone. It's 10:43 AM, and actually this is the required solution for this particular question, and that's how you are really supposed to solve about that. For me, I believe that was really an interesting one, especially getting to know how to subtract time and to be able to know whether you can be able to convert the lost seconds, whether you can be able to pile them up together. But even more importantly, this is where the trick for this particular question was, and that is whether you are supposed to take these 37 minutes and add them to the actual time, or whether you are supposed to subtract them, because you'll find a number of students getting to add these 37 minutes, and that will definitely make you to lose your mark for the answer. So for this particular case, that's how you are really supposed to handle about that. Let's open up the question that follows, and that is question 10. Oh, we are told that in the figure below, line AB is equals to 5 centimeters is a side of a triangle ABC in which BAC is equals to 120 degrees and line BC is equals to 10 centimeters. Then we are told use a pair of compasses and a ruler. This is very important. Use a pair of compasses and a ruler. Complete triangle ABC and hence measure the size of angle ABC. So this is a question that is really requiring us to do some measurements. Let me see if we can be able to get into this because it will require us to have some tools, and that is the pair of compasses and also a ruler. And it might take a while before I get to go to that software where I'm able to do that. So what I'll just get to do is to guide you step by step in a way that you'll be able to understand fully on how you are really supposed to go about this. So it's important that we go all along together. So we have part A and B here. That is line AB. This is supposed to be 5 centimeter. So this is interesting because line AB has already been plotted for you, therefore it actually makes your work easier. And then we are told that the triangle is BAC. So we have a C somewhere that we don't know, but maybe assume that C is maybe along this line, but let's not pinpoint where it is exactly for now because we have not yet checked into that. But then we are told that BAC is equals to 120 degrees. Therefore, BAC is supposed to be 120. So there's supposed to be an angle here such that this angle is 120. But there is something interesting over here which you're really supposed to follow, and check here very keenly. We are supposed to use a pair of compass and just a ruler. You're not supposed to use a protractor. So the moment that you come here and put a protractor, therefore that implies that you are going to lose the method's mark. Therefore, you should be able to work it out using compass and a ruler. But how are you really supposed to do that? You see, getting to plot 120 degrees directly using a compass and a ruler, it's almost very hard to plot it directly. So what you do is that you extend this line a little bit like this with some dotted line. And once you extend it like that, you come here with your pair of compasses, and then you create an angle of 60 degrees here because it's much easy to create the angle for 60 degrees. It's easy to do that. It's actually so much doable. Because normally what you usually do is that you will come, you will have your pair of compass. Let's say you have one side of it being here, and then the drawing side here, you make a mark. After you make a mark, using the same length over here, you make an arc somewhere, and also you use the same, actually that arc most likely it's supposed to lie along here because you are measuring the same length from here to here. You make a mark upwards, and also when you're here you make an arc like that, and then what you do, you join that arc at the point of intersection of those arcs. You join it with this part. What you are going to have here is 60 degrees, and definitely because this one is a straight line, automatically the angle that will be here is 120 degrees. Therefore, you must show that you first plotted these 60 degrees, because actually there's no any better way out other than that. So that will show that what really remained here is 120 degrees, so that this line is 180 degrees. But then let's go ahead and read the question. So BSC is 120 degrees. So this is a line that you don't know its length, so it just gets to extend to somewhere there. And the next statement is what is going to guide us where we are going to locate our C. We are told that BC is equals to 10 centimeters. So you are going to come here with your ruler and measure from 0 centimeters, you measure 10 centimeters upwards. So that is going to be somehow a double of AB. So if AB is from here to here, so we would say that is A bits from here to here, therefore you extend another point like that. So you'll find like AB, it's supposed to be around that point, and therefore what you'd say that this is point C, and finally you join this point C, you join it very straight with the line B. This is interesting. So what I've done here is that I've not used the pairs of compasses and a ruler. This is just an illustration on how you're supposed to go about that. And finally, you are going to come here and measure this angle that is here. And notice that you are supposed to place your compass like this, such that this tip is really, there is a line that is usually here, such that that line is really matching with this line like that. And ensure that the scale that you are measuring with, you see there's usually the inner scale and the outer scale. So the scale that you're going to use is the scale that is moving from 0, that is from the left side, the one that is moving from 0, 10, 5, 10, 15, like that. That's the scale that you're going to use, and you're supposed to measure this angle. So kindly try that later on your own and try to measure that angle. Personally, when I did it on a piece of paper, it's giving me 34.6 degrees. But normally, the answer that is given, and actually I believe this is what was used to do the marking, it's usually given as plus or minus 1. So if you get 34.5, 34.7, that's also quite accepted. So if you get 34.5, 34.6, 34.7, all this is very correct. But if you go something beyond this, either downwards or upwards, then that may not be given as a mark, because you really need to be accurate on that. So that's the structure that you're supposed to have, and that's how you are really supposed to go about that. So for your practice, it's important you know how to create 30 degrees, 60 degrees, 90 degrees without using a protractor, because it is through this that you are able to derive other angles like 45. So if you know how to construct these angles, you can always be able to construct other angles like 120 degrees, like 135 degrees, like 150 degrees, because all this is a derivation of this. For instance, 120, we get it by doing 180 minus 60. So if you know 60, you can plot 120. 135, we get it by plotting 90 and then 45, like that. For 150, you get it by doing 180 minus 30. So if you know how to plot that, you can be able to plot 150. So it's important that you also get to know about how to plot other angles like 30, 60, 90, and 45 as well. That is really quite important. For now, let's move on and keep going on these very wonderful and amazing questions that we are really having here. So here is another very wonderful, very good question for our practice. We are told that a shopkeeper bought an item from a wholesaler, and then we are told if the shopkeeper sells the item at shillings 2,470, he would make a profit of shillings 3x. The question goes ahead and tells us if the shopkeeper sells the item at shillings 23.40, he would make a loss of 2x. Determine the amount that the shopkeeper paid for the item. Let me help you bisect this question, because this is now the role of now mathematics, getting to simplify all these sentences into some mathematical terms. So if the shopkeeper sells the item at this amount, therefore that would imply that this would be the selling price of this item. If then the selling price of the item is 24.70, he would make a profit of 3x. But if the selling price, in accordance to the question, but if the selling price is 23.40, oh, the shopkeeper would make a loss. This is quite unfortunate. Would make a loss of 2x. I don't know if you guys really sympathize with the shopkeeper, but let's see where this question is leading us to. So one thing that we really need to find is the amount that the shopkeeper paid for the item. In other terms, the amount that the shopkeeper paid for the item, that is definitely the buying price. So the question is actually hiding out the word buying price, and that is what they want us to find. And I believe that we can be able to do that. But how can we really be able to do that? Let's get into it. So we are having the selling price is 24.70. You'd make a profit of 3x. But now we have to ask ourselves, how do we get the profit? Therefore, that would imply for this person to make a profit. I hope that you get this right. For this shopkeeper to make profit, then that would imply that the selling price, this is the price that he is selling that item, it is higher than the buying price. So we do the selling price minus buying price so that we can get the profit. Amazing. I believe that you do get that. We do the selling price minus the buying price so that we can get the profit. This is how we get the profit. So that would imply that what's the selling price here? The selling price here is 24.70 minus buying price. Do you know the buying price? Not really. That's actually what you are finding. The profit is 3x. Actually, do you know the profit? Not really. But we just have it as an expression, 3x. But at least we have formed something that looks quite good. Let's go ahead and see what we can do with this information. Oh, this is now the mournful part, and the part that is a bit quite not cool, making the loss, but we really have to work with this information. So that this person can make the loss, then that implies that the buying price is higher, because we do buying price minus the selling price. This is what really gives us the loss. The buying price minus the selling price, this is what gives us the loss. Therefore, that would imply that what's the buying price? We don't know actually. What about the selling price? It's 23.40. What about the loss? 2x. This is good, because we have now two different expressions, or rather equations. Here we can try to make buying price the subject of the formula. We can take it to the other side such that you're going to have buying price is equals to, if we take it to the other side, then 3x should come to the other side to have 24.70 minus 3x. For this case, we have buying price is equivalent to we pick 2340 to the other side. That's gonna give us 2340 plus 2x, like that. So this is buying price. Great, amazing. Do you see what I can see? I believe that you can see that. Amazing. Because we have buying price over here. This is an equation for buying price, and also this is an equation for the buying price, like that. So that implies that if this one is equivalent to buying price and this one is equivalent to buying price, therefore that would imply that 2470 minus 3x should be equivalent to 2340 minus 2x, or rather plus 2x. Actually, this is plus 2x. So we can try and simplify. We have 3x, taking it to the other side to have 3x plus 2x is equivalent to, what do we do it to this part? 2340 to this side, we have 2470 minus 2340, like that. 3 plus 2, that's 5x, is equivalent to 2470. This is 2470 minus 2340. This is giving me 400. Divide by 5, divide by 5. X is equivalent to 40 divided by 5. That's supposed to give me 80. So we have already found the value of x, which is 80 shillings. But the question is requiring us the amount the shopkeeper paid for the item, and that is the buying price. So we can use either of these. We have 2470 minus 3x, or this one. Which one would you like us to use between this one and this one? Personally, I don't know why. I don't like doing a lot of subtraction, therefore I would choose to go with this one where we are having addition. So buying price will be equivalent to 2340 plus 2 multiplied by 80. 80 by 2, that's 160. 160, if we add it here, it's like 2300 plus 200, which will give you shillings 2500. And actually, if you replace this x with this case where we have in subtraction, let's check it out here. What you're having here is 2340 plus 2 times 2, 2 times 80. 80 times 2, that's 160. 160 plus 340, this is 340 plus 160, that's supposed to be 500, and we have this 2000, therefore this is 2500. Yeah, that's really how it's really supposed to be. And that's the supposed solution for that, and this becomes our buying price, and that is the real required solution for that. And I believe that you are really able to follow through until this point, that you've really been able to get the solution for that, and that is the required solution. Shall we move on to the next part? That is question 12. Question 12, a very wonderful and interesting question over here, and that is we are having the following table shows the frequency distribution of marks scored by students in a mathematics test. And then we are told that the frequencies for two classes are not shown. And then we are told that the table also shows the height of each rectangular bar of a histogram drawn to represent the information on the marks scored by students. You are told calculate the missing frequencies. Calculate the missing frequencies. We have the height of the bar, and we have the marks. One thing that you're really supposed to know is how to calculate the frequency. So you see, this one is what we call a histogram. and it have got a rectangular bar. So a rectangular bar, it's something that looks like this. Like that. So normally, to be able to find the frequency, what we usually do is that we usually calculate the width of that bar and we multiply by the height of that bar, like that. You see, for instance, like this bar, it's 1.4. Oh, actually, there's no any bar that has really been worked out. Okay, that's all right. No worries. The height of this bar is 1.4. And then we have to calculate the width of this bar. The width of this bar, what we usually do is that we usually take the upper limit and we minus the lower limit for that particular class. So if it's for this one, to be able to get the lower limit for the lower class, it's 9.5. So this would be 9.5. The upper limit for this is 14.5. So let's actually talk it in terms of bars. Let's talk of bar 1. So bar 1 will have 14.5 minus 9.5 multiplied by 1.4. I'll actually show you a better, quicker way out on this very shortly. So 14.5 minus 9.5, what do we get here? It's supposed to be 5 times 1.4. And this is going to give me, this is like 14 times 5. This is like 7 times 10. That's like 70. And then we minus the 0 to get 7. So the frequency for this one is a 7. That's bar 1. We go to bar 2. Bar 2, what you're having here is 19.5 minus 14.5. Remember, we are taking the upper class limit for this minus the lower class limit for this, and then we multiply by the height of that bar, which is 2. This is going to give me 19.5 minus 14.5. I believe that's supposed to be 5. 5 multiplied by 2, that's gonna give me a 10. Therefore, I write a 10 there. Finally, I move on to bar 3. Bar 3, I have 29.5 minus 19.5, and this is multiplied by 1.5. Let's try to work it out together. And here you have to be a bit careful. You see, this one is a bit larger because this one is going to give you a 10 and then multiplied by 1.5, and this is going to give you 15. 15, like that. So actually, we are told to calculate the missing frequencies. I believe that we've really been able to do that. And that is 7, 10, and 15. Is there anything the question requires us to do? Not really. We've been able to calculate that, and that is the required solution. So here you see that you are finding the lower limit, the upper limit, the lower limit, upper limit, lower limit, upper limit. You can always go ahead and do 4, 14 minus 10, that's 4. And you simply add 1 to get 5. And then you say 5 times 1.4 is 7. Same case with this one. You just get to do 19 minus 15, that's 4 plus 1, 5. 5 times 2, that's 10. Same case with this one. The difference here is 9 plus 1, which is 10. 10 multiplied by 1.5 is equals to 15. So that's just a quicker way out to confirm whether you really did the right thing, because as you do subtractions here, especially for the decimals, it might maybe make you to be prone to make an error, but I'm hoping that you will not do that. But that is exactly the solution for this particular question. This question, I see that it was really worth 3 marks, such that if you work out this, you get a mark. You get a mark for that. and finally a final mark for that particular part. Oh, this is amazing. We've not done any questions so far about transformation and anything that is relating to that, but I believe here is a good opportunity because there's a question that is asking something that is relating to that, and let's find out. We are told that on the following grid, line A prime, C prime is part of A prime, B prime, C prime, and then we are told triangle A prime, B prime, C prime is the image of triangle ABC after a reflection along a mirror line. How unfortunate is it that you use a mirror every day to check it yourself, but this one becomes a challenge? Uh, I hope that's not the case. So I believe that we'll be able to really bisect it so well. And let's just get into it and see how it goes. Like so, even the shapes they're usually subjected to a mirror. That's really so amazing. I don't know what they would say about themselves if they could be talking, if they had the ability to talk, and then they are given a mirror and then they are told, say something. I think that would really be so much interesting to see shapes talking. Maybe they would say, I'm an equilateral triangle, I'm a scalene. Oh, that's so wonderful. So let's get into this right away. So we are having this triangle that is ABC. It's right here. We are told it's actually this one is actually the image. No, this one is the image. Triangle A prime, B prime, C prime is the image. So this is the triangle that is lying over here. It's right here. It's the image of triangle ABC after reflection along a mirror line. So we don't have a question actually so far. Let's go ahead and see how the question is requiring us. On the same grid, draw the mirror line and hence complete angle. I hope that you can be able to see where the question is. It's right here. And complete triangle A prime, B prime, and C prime. I'm a bit curious to know if there's a question that follows after that. That is no. So that's the question for this particular part. And how many marks is that? 3 marks. We are good to go. Let's get into it. So we are supposed to complete this triangle A prime, B prime, and C prime. But unfortunately, we don't know where B is. But there's something that we know that this mirror is somewhere in between these shapes over here. So normally, what you're supposed to do, I wish I could really illustrate this in a whiteboard or rather in a board, but I'll be able to guide you step by step until you are really able to understand how you should go about it. I believe that if you follow keenly, you'll never have any challenge with questions that are involving a mirror line because this is the exact method that you use for all questions that are involving reflection, especially of this particular nature. So the first thing that you do is to connect all the given points. Let's say you have this one. So you're supposed to connect this one, A, you connect it with this A, like that. Actually, you are supposed to connect with dotted line, but for my case, because I want to try, even though it is a sketch, I want to be a bit more accurate, I'll go ahead and connect with a straight line. But for your case, just you're supposed to connect with some dotted line, and you can be able to do that. You just place a ruler here, and then you mark your pen like this. It's much easier for you. But since what I'm using now, I don't have a ruler and I need my line to be a bit more straight, I'll go ahead and connect like that. So that's what you're really supposed to do. Same case with C. Um, C, you're supposed to connect that along until you get to this point over here. So let's go ahead and do that. So this C is going to really come like that. you connect it with this C like that. And finally, you are supposed to establish a mirror line along this line. So what are you really supposed to do? So you are supposed to bisect this line, and also you bisect this line. You know, if you bisect this line into two, it's going to pass along the center of this line. Same case with this one. And something interesting is that this line, it's supposed to be actually the same line. If you bisect this line, you'll get a line that is passing across this way. Same case with this one. If you bisect this line, it's supposed to cut across this way. And it's going to pass along the same place, And actually, let's go ahead and do that. But I'm a bit not so much satisfied with my first line. Allow me to plot it because I need to really show it accurately, even though it is just a plot. Okay, so this line, it's supposed to move from here to here. So normally this line, it's supposed to come this way. Ah, great, amazing. Yeah, at least I'm a bit more satisfied because it's supposed to pass along that path. So finally, what you do is that you come here with your pair of compass. Actually, you can do this without a compass. I'll show you the trick. You come here with a pair of compass. You extend, you open it a bit, like almost as surpassing the halfway, and then you make an arc somewhere, and also you make an arc somewhere like that, and also you come at this point, you make another arc, and also here you make another arc. So once you make these arcs, you combine them, or rather you get to join them. Like for instance here, you're supposed to join this arc, you join it with this other arc like that. And for your information, do you know that this one is almost accurate? There's a way that I can be able to tell that that line is going to pass exactly there. But that is exactly what you do. Notice that this one becomes the mirror line. By so doing, you already have your mark for that. So you also need to be able to get the other marks. You see, this B, the more something is more nearer to the mirror line, that's the way that it's more nearer to the image. I hope that you realize that. You see, this C, it's so far from the image, therefore, this C, which is the symbol or rather the object, it's far from the mirror line, and because it is far from the mirror line, its image will be even more far from the mirror line in an equal measure. So if you could measure this line from here to here, it should be equivalent with this line from here to here. That's something you can tell. Even this line from here to here, it's equivalent with the line from here to here. And actually, that is how I was able to know that this line is somehow quite accurate, because it's supposed to pass at the middle of this line here, from here to here. So finally, what is remaining for us is to establish where this B should be located. So in order to locate where this B should be, what you do is that you come with your pair of compass, you measure the length from here to here, and now you extend that with, you measure the length from here to here. Once you identify that length, you measure an equivalent length from this point now downwards, and you are going to notice that she's going to lie around that place, because from here to here it's around this place, and that automatically becomes your B. And I'll actually get to show you how you can be able to confirm whether that is true. Finally, you join that part with this part. So finally, the part, or rather the image that you're really supposed to get, is now this one. That is A prime. This is A prime. It is joining with this part over here, that is B prime, and B prime, it is joining with C prime, and C prime, it's connecting with now the A prime. That's the triangle that you're really supposed to get. Now, can I show you how to confirm whether you actually got the right shape? Yeah, you should go ahead and do that. So you should come here with your compass, you open it up like that. Once you open it up, you'll notice that the length from here to here, it's equivalent to the length from here to here. Same case when you are at this point, the length from here to B is equivalent with the length from here to B prime. Same case when you are here, it's the length from this mirror line to C, it's equivalent to the length from this mirror line to the C prime, which is right here. And another way to also double confirm that that is really right, once you come here where we have the object, you will notice that from the object where we have point C, the units that are from point C to B are 1, 2. 1, 2, once you count it vertically. And the same case once you come here, B to C, they are vertically 1, 2. What about horizontally? Horizontally, it's from this point. You see, this is the horizontal part of it, and we are working with B. The horizontal part of it is this one. So how many points, how many units are these? 1, 2, 3, 4. What about here? That is B to A. This is now where the image is, that is point B and point A. This is a trick that you used to employ to mark for yourself whether you actually really got it right. So how many points are there? 1, 2, 3, 4. So you'll notice that they are equivalent. All these things should really go hand in hand, and that is actually what really makes mathematics to be much juicy and something that is really so much cool and interesting, because you can see a lot of patterns that are here, and quite a lot, because even for this one you can see that these are 2 units, or rather 2 square units, 1, 2, and then this line is supposed to cut it across from one end to the other. Same case with this one, 1, 2 units, and it's supposed to cut them across together like that. And that is the trick that I actually used to know that that line is going to pass via this route over here. And let me actually show you the actual trick that I used to know that that line will pass across here. Because when you look at this part, these are how many boxes that this line is cutting across. It's cutting through across box 1, box 2, box 3, and box 4. Therefore, I just knew automatically that the middle part will be at the point between box 3 and box 4. And the part where box 3 and box 2 meet is definitely here. Therefore, that should be the center. And actually, you can repeat that for B and B prime, C and C prime. It's going to give you the same thing. And that is really quite interesting. For now, we need to move on to the other question so that we can be able to also learn another tip from it. And we have it right here. So we are told that the figure below represents a prism ABCDEFGH, and then we are told that the cross section of the prism is a trapezium. And then the question goes really ahead to tell us that BC is equals to CF. Can you locate where BC is? BC is equals to CF. Where is CF? Oh, amazing, CF. That's quite important. So this one is equivalent to that. Okay. And then we are told that AD is equals to HE. AD is equals to HE. That's pretty good. And then we are told that AB is equals to DC. AB, 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 it's there. AB is equals to DC. Where is DC? DC is right here. Okay, that's quite good. Is equals to 2.5 centimeters. Okay. What about that? Draw a labeled net of the prism. Do we have a tied question to this? Let's check out. Not really. So this is the question that you're really supposed to deal with so that we can be able to have our full marks. Okay. So let's go ahead and plot the net of that prism. So this is the cool thing about maths, because as you also get to deal with numbers, you are also becoming a doctor in a way, because you are also getting to conduct some surgeries. But now the surgeries that you are conducting are now for shapes. So you want to conduct a surgery to this shape such that we can be able to cut it along this line, and then we cut along this line. We cut along this line. Once we cut here, check where this cursor is moving through. If you cut along this line and this line and this line, what is going to happen is that the whole of this shape that is there is going to fall on the right side. And actually, that is how you visualize these shapes, such that what you're going to get is that this one, suppose now you are going to cut across those lines like that, such that you are going to remain with this base. You remember that we've been told that this one is 5 centimeters and this one is 5 centimeters. So what you should be able to have here is, this is a sketch. Actually, we can just do it all together. Because we already know what the question is requiring us to do, we can get to utilize this space over here. Okay, we have it right there. So what we have here is we start with the base, that is 5 centimeters by 5 centimeters. So that is going to look like this. It's somehow like a square. It is indeed a square. 5 centimeter, 5 centimeter. And what's this? This is, okay, we also really need to label this shape, because this is GF. Or actually, we'll do the labeling later on. But this is basically it. You see that this part is 5 centimeters and this part is 2.5 centimeters. This is this line. You really need to visualize this. Therefore, when this flap, can I label it for you? Let me try. But I don't want to really interfere with the shape, but I want you to visualize the shape CD EF. Look at that. CDEF. CDEF. This is what we are currently plotting. CDEF, if we open it up, it's going to be a rectangle. It's going to be a rectangle with this line being 5, and then this line which is here, 2.5, it's going to be extending like that. And this other one here, it's going to extend like this. You know which line this is? This is this line over here, from here to here, because it is falling on the right side, which is 2.5. So it's going to fall like that, and this is going to be like that. And finally, there's this other part that is upper here. Again, this part here, you see this is 2 centimeters, 2 centimeters. So in short, this part will look like this. This is the best way to go about that, so that you visualize well. This part is going to be 2.5. And what about the length? The length is equivalent to 5. It's going to be 5. Therefore, if we bring it here, it's going to look like this, such that this one is again 5 centimeters, but now from here to here it's 2 centimeters. Okay, the part that is now remaining is now this other flap. You see the plane figure ABGH. Just visualize that, ABGH, ABGH. When it falls on the left side, it's going to be like this. Where you have the length from here to here, this is the length. It becomes now this part, 2.5. And this length over here, this one, I'll actually write it down here for you to see it actually much better. This one is also 2.5. and this length here is 5 centimeters. So this is the part that is connecting to this line. Therefore, we just drift this one swiftly and I will bring it there to have 2.5. Finally, what you are remaining with is now this plain figure here. For this one, I can label because I'm not going to use the diagram again so much. So remember that the part that we are having here is BC. Let me actually try to label it differently so that you don't confuse it. So the part that I'm having, this is the shape that I've really opened up such that I'll have this BC going here. And then I have GF. And then I have E. And E, I have H. From H, at this part of C, I have D and A. I'll explain this to you very shortly. And then from this B, this is the part that comes after that. Okay, that's really amazing. So let's go ahead and also open up these other shapes that are like this. If we are really to open up this flap and this other flap, you see this is BC. You see where BC is lying? It is this line. And now I want this shape now. If I could really demonstrate this in a 3D way, this shape is going to now become like this. It's going to, if it falls down, like this part that is kind of standing up, it now falls down. You're going to get something like this. I hope that you visualize that such that this is going to remain as BC, and then this part is A and D. It's like this part has been cut and this part has been cut like that, such that this one is going to fall on the left side like that. So if we are really to employ that in our part here, that part is going to be like this. Like that, such that we have AD there. Same case with this other part, the upper side here. If this part is brought down on the right side, we are going to have a shape that is extending upwards, like that. And from this is point G, you don't forget, G up at the upper side of it is H, and this is a point F. The other end of it is point E. So this is actually the shape that you're really going to get. And as you do this, you see what you have been told is to draw. It is not to plot, it is to draw. Therefore, you should be able to draw it to scale. And to be able to draw it to scale, it's pretty much easier because you already have a sketch of it. And you know that this one is 5 centimeters, 5 centimeters. I believe that it's quite easy to plot a square that is 5 centimeters by 5 centimeters, and then from there you extend 2.5 centimeters, you label point E, you extend another 2 centimeters, you label point H. Same case with this part that is here. Maybe the only part that is likely to give you some little challenge is plotting this shape over here to scale, and that's what I really want to show you right now. You see, what you're really supposed to know is that from F to E, it's supposed to be 2.5 centimeters, 2.5. Also, this is 2.5, this is 2 centimeters, this is 2.5, this is 2.5, and here is 2 centimeters. So to be able to plot this part is the only one that is likely to give you a small challenge. So what you'll do, this is quite interesting. You'll take your pair of compass and then you measure 2.5 centimeters using your ruler. And once you measure that, you make an arc somewhere there. You make an arc. Same case with this one. You have one side, one tip of the compass pointing at this part where you have point G, and then you make an arc using the other part such that it is 2.5, like that. And then from there, you are really supposed to know the center between this part and this. This is 2.5. So you're going to come and measure 2.5 centimeters from here, 2.5 centimeters, which is the middle part here. And then once you measure that, you measure 2 centimeters upwards. That's where the line for this particular point should pass through, because you want to have you want to know the length from here to here. Actually, to be able to approximate quite better and exactly, we want to know the middle part. So once you have measured 2.5 centimeters here, 2.5 centimeters here, you can just draw like a small line and just know that that is really the center for that. That is the center part. And you want to have 2 centimeters here. So if you really want to have 2 centimeters here, one thing that you really need to know is that from this point to this point here, it should be equivalent to from this point to this point. And at the same time, the from this point to this point, it should be 1 centimeters and 1 centimeters, like that. So how can you be able to use that information to ensure that what you plot here is 2 centimeters? So you'll come with a pair of compass and measure 2 centimeters and come with it along this line and see where it is quite fitting. And then if you see that it is exactly 2 centimeters, as you get to stretch it a bit downwards towards the center, then that's where that line is going to pass, such that it is going to pass on this arc like that. And that is going to give you your center point where you measure 1 centimeters and 1 centimeters, and that is going to give you this other part. But again, you can always get to confirm that you really did the right thing with that. But again, there's also another strategy that you can use. You can pick out this part over here. This is the shape that you want to measure, and you want it to be very accurate, like this. This is the shape that you want to create, and you already know that this part is 2.5, and this is 5 centimeters, and this is 2 centimeters, and this is 2.5 centimeters, like that. So you can come here and put a line here and put a line here. This is another way to plot this shape over here, such that this one will be 2 centimeters. If this is 2 centimeters, the centimeters that remain are 3, because the whole of this is 3. And since this one is is equivalent to this line are of equal length, then that would imply that from here to here is 1.5 and 1.5. Therefore, what you'll do is that you'll just come here and measure from here to here 1.5, and then you stretch a line upwards like that. That will be the point. And then you come here, you measure 1.5 centimeters, you stretch upwards and know that that line is going to pass via that point. And then definitely what you just require now to measure is 2.5 centimeters from here, and you make a mark where they are going to meet. I believe that really explains to you how you are really supposed to make this shape. For this others, it is quite straightforward and quite easy. Yeah, maybe this one is what required some more explanation, of which I believe you've been able to understand that. But then again, if you still have some trouble with that, I can make another separate video where I'm really explaining much deeply as I actually do it practically, so that you can be able to follow along with that. But that is exactly what you're really supposed to do in order to be able to get all these 3 marks for that particular question. Let's move on to question 15. We have it right here, and let's see the skill that you're really going to learn from this. I believe this will be a very interesting question. We are told that in the figure below, a triangle ABC, it's right here, it's good to visualize as you read. ABC is a right angle at B, so it is a right angle at this point. And we are told that AB is equals to 8 centimeters. That's pretty good. D is a point on AC. D is a point on AC such that AD is 5 centimeters. So from here to here, that's what we have, 5. And the area of triangle ABD is ABD. Where is ABD? It's this one. We are told that this area here, the shaded part, is equivalent to 10 centimeters squared. And then the question goes ahead and tells us, calculate the length of BC. Okay, that's really pretty good. But there's something that is really popping up in my mind. I don't know. How would you go about such a question where you're really supposed to calculate the length of BC with this information? Would you like to give it a thought? It's important. Well, but let's just get to check into it. So what you're really supposed to do is to first find out what we can be able to calculate with the information that we have. Is there any side or maybe something that we can be able to calculate using the information that we have? Because it is through that we'll be able to get the length of side BC, because it's not quite easy to calculate directly BC, but if we could get something extra from the information that we have, that extra element that we are going to get, it is what is going to help us to calculate the side of BC. But the fact that we have the area, we have to ask ourselves, how do we find the area of a triangle? It is a half base times height. But here we don't have the height, even though we may get the base. So the other way out to calculate the area of a triangle, it is doing a half AB sine theta. Let's see what this is going to give us, something very interesting. We are told that this one, a half AB sine theta, this is the area of this triangle. It's supposed to give us 10 centimeters. Let's go ahead and replace the values that we have to be able to get the value that we do not have. So for our case, AB will be this length, that is 5, and our B will be this length from here to here, which is 8. We don't have sine theta, we just write sine theta is equals to 10. Amazing, we can divide by 2 to get 1, divide by 2 to get 4. So we have 20 sine theta is equals to 10. What can we get from this information? We can divide by 20, divide by 20 to get sine theta is equals to a half. Oh, great. It's actually really connecting well, because that would mean theta is equivalent to antisine of a half. Can we work out the antisine of a half? I believe that's quite possible. Antisine of a half, that's gonna give me 30 degrees. Therefore, that implies that this side is 30 degrees. Therefore, that implies that if I'm to have this shape, I'm going to have it like this. This is 30 degrees, this is 90 degrees, this is 80 centimeters, and I'm supposed to find the length of BC. BC, it is this one. Let me call it height. So I ask myself, how can I be able to relate this angle, the height, and this length? Definitely, because I'm using this angle, I'm going to use SOHCAHTOA. You remember SOHCAHTOA? I ask myself, I've got the opposite of this side and adjacent, opposite and adjacent. Opposite, so I put a line where I've got O and A, O and A, O and A. Definitely this is where we get both of them being together, O and A. Therefore, we are going to use the relationship that tan theta is equals to opposite, and opposite is h, over adjacent, which is 8. Therefore, that would imply that h would be equivalent to 8 multiplied by tan theta, and tan theta here is now 60. We go ahead and work out this. 8 times tan 60, we can go ahead and feed that to our calculator directly, and that is going to give us 4.619 centimeters. So if you leave it at that, it's very okay, and that is how you are really supposed to solve about that. So the key thing that we really learn from this is that when you've got any question, it doesn't matter the kind of question it is, the first thing that you really check is the things that you can be able to get from the information that you have. Because you see, if we really tried to find the length of side BC directly, it would have given us quite a hard time. But now, since we've been able to use the information that we have to be able to get this angle that is right there, it becomes now much easier to find the length of side BC. And that is such a great and wonderful approach to go about that. And that is the required solution for that. Yeah, I believe that we can get to move on with the next question. This is question 16. We have a question tied to that. And actually, this is the last question in section A. And let's go ahead and find out what this question is requiring us to do. Okay. I'm already so much thrilled about the question even before I read it, but let's check it out together. We are told that the quadratic curve y is equals to 3x squared minus 4x passes through the point P, 1, negative 1. We are then told determine the equation of a tangent of the curve at point P, leaving the answer in the form of ax plus by is equals to c, where a, b, and c are scalars. Great, amazing. So what you're really having here is now a quadratic curve of this nature, and we are told that it is passing through the point P, 1, negative 1, and we are told to determine the equation of a tangent to the curve at point P, leaving the answer in the form of ax plus by plus c, where a, b, and c are scalars. So to be able to find the equation of this point P, we should be able to know one extra thing. And do you know what that is? It is definitely the gradient of this point P. If you can be able to get the gradient of this point, then we can be able to find its equation, because we have 1 point. And we know that to get an equation of any line, we require to have either the 2 points. If we don't have the 2 points, then we should have a gradient and either of the points. So for this particular case, we have not been given the gradient, and also we've not been given the other points. But there is one thing that we can be able to get from this, and that we can be able to get the gradient of this curve. And once we get the gradient of this curve, we are going to be able to find the gradient of this point P. So let's go ahead and try to find the gradient of this curve. We have y is equals to 3x squared minus 4x. So the gradient, we find it in terms of change in y over change in x. So what we are doing here is differentiating. I hope that you do remember how we differentiate. We multiply the power by the coefficient of x for this matter to get 3 times 2, that's gonna give us a 6. We retain that x, but we minus the power by 1. If this was 2, then that will just be 2 power 2 minus 1, which will give you 2 power 1, which doesn't make a lot of difference when we just write x like that. And finally minus, if we don't have a power here, so it's simply like 4 times 1, which is 4. And then here, this x, we are going to have it, if this was x to power 1, then we minus 1, this is x to power 0, and you see x to power 0 is just a 1, therefore 4 times 1 doesn't change much, it just remains to be just a 4. Therefore the gradient for this line, or rather the equation for this one, when it is differentiated, it becomes 6x minus 4, and this becomes now our gradient. But now remember that this gradient we can always call it for this gradient, what we have is that we know the value of x because we know that it is passing through 1, negative 1, and the value of x here is a 1, therefore we replace by 1 to get the actual gradient in terms of something that is really measurable. So we have 6 multiplied by 1, that's 6, minus 4, that's 2. Therefore, the gradient for the quadratic curve is equals to 2. That's what we have. But now we know that this quadratic curve, it is passing through the point P, 1, negative 1. And what does that tell us? If it is passing through this point P, 1, negative 1, then that implies that the gradient of that particular point, P, 1, negative 1, it's right here, P, 1, negative 1, it should be 1, it should be 2 also. But well, to be able to find the gradient of now this line, that is this line that is passing through P1, negative 1, what we really need to do, or actually what we really need to do is to have the other point, but now since we don't have, we let that to be xy, like that. Amazing. Let's go ahead and now find the equation of this line. And I hope that you do remember which line this is. Remember that this one is going to give us the equation of the tangent to the curve. It's going to give us the equation of the tangent to the curve. So let's go ahead and work out this. So what we have here is 1 minus minus 1. And what we have here is x minus 1 is equivalent to 2. So when we've got two consecutive minuses, it automatically becomes a plus. So what we have here is y plus 1 is equivalent to 2 multiplied by x minus 1, that's going to give you a 2x minus 2. So we have y is equals to 2x, and then we have minus 2, and then we take this one to the other side to have minus 1. Finally, we have y is equals to 2x minus 3. And actually, that's the required equation, and I believe that we've really been able to get that. But now you have to go back to the question, which is quite important. You are told that do that, leaving the answer in the form of ax plus by is equals to c. So you are supposed to leave it in this way. And what we have here is y is equals to 2x minus 3. So to be able to convert it in this format, what we shall need to do is that we need to have this negative 3 being on one side and then y coming to this other side, such that we are going to have negative 3 is equals to 2x. Actually, what we are doing here, once you take this negative 3 to this side, it's going to be a positive, and this 2x, it's going to remain the same way it is because we are not changing its side. And then we pick y, we take it to this other side to have minus y, and then remember that we have to start with the right hand side so that it can be able to match this equation. Therefore, we start with 2x minus y is equals to 3, and this is now the right format which matches this format that is required right here, and that is now the required solution for that, and that is question 16 for our section A for KCSE 2025 paper 1. So this video really gets to explain all the solutions for all the questions that were tested in the KCSE 2025 paper 1, that is section A. So what we'll do is that we'll have now another one that will be now explaining about, or rather getting to tackle questions that were there in section 2, which are really quite important because those questions are the questions that get to give you 10 marks in just a single question. So ensure that you also get to follow through keenly, and you get to follow up with section 2 also. Don't leave it at that, and I believe that you are really able to elevate your mathematics skills, and also you are able to build your confidence by getting to follow all along, and also you are able to find how you are really supposed to tackle these questions. And we'll get to put a link just below this video where you can get the link for the video that is now covering section 2. Yeah, continue being here at KCSE Mathematics, where we continue to make mathematics more fun and more enjoyable. Until next time, bye bye for now.